Hello everyone, welcome to this channel. This question has been taken from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 7. The question is, in presence of a uniform horizontal electric field E, a small non-conducting disk of mass m and charge q is released on a non-conducting triangular prism of mass m placed on a frictionless horizontal floor as shown in the figure. Slant face of the prism makes an angle theta with the horizontal, and coefficient of friction between the disk and the slant face is mu. If the disk accelerates up the slant face, find the acceleration of the prism. So let us solve this question. We have collected all the data from the question here. Prism is having mass m. Non-conducting disk of mass m. So this is non-conducting disk, and it is having a charge q on it. Disk is released on the slope of the prism as shown in the diagram. Uniform E field is in the horizontal direction, that has been shown here. Slant surface of the prism is having coefficient of friction mu. So this surface is having coefficient of friction mu. Horizontal surface is frictionless. This surface is frictionless. We have taken perpendicular to the slant face as axis y and parallel to the slant face as axis x. The forces acting on the disk has been shown in the figure 1 for your convenience. These are the forces like QE is the electrostatic force, mg is the gravitation force, N is the normal reaction from the prism to the disk, Fr is the friction force on the disk, because the disk has been said in the question moving, accelerating upwards. So friction force will be opposite. So Fr has been shown in this direction. We have assumed that the prism is moving with an acceleration a in the horizontal direction. So ma will be the pseudo force on the disk. Further, for convenience, free body diagram of the disk has been made. Disk has been enlarged here for easy viewing. So sum of the forces on the disk, if we calculate in the y direction with respect to the frame attached to the prism, means frame if we are attaching with the prism, and from there we observe the motion of disk, we can write that summation of Fy is equal to 0. Why? Because when your frame is attached to disk, there is no motion you observe in the y direction for the disk. Now in the y direction, which all forces are acting on disk, we will write. The pseudo force is acting in this direction. This angle is theta, so this will be 90 minus theta, so ma sine theta will be the component in this direction for ma. Normal force is acting in the y direction, we can straight away write like this. Electrostatic force is acting in this direction, the component of this will be in the negative of the normal reaction direction, so we can write minus q is sine theta. Same way mg is having a component in this direction, mg cos theta, but it is acting negative to the y-axis direction, so minus mg cos theta. This equation we say it as 1. This is the free body diagram of the prism. Which all forces will act on this prism? Prism is offering a normal reaction force on the disk. So disk, as per Newton's third law, will exert a force N on the prism in this direction as shown in this diagram. Friction force on the disc by the prism is in this direction. So therefore the friction force on the prism by the disc will be in this direction. The sum of forces in the horizontal direction on prism, if we write summation of Fh is equal to n sine theta, the component of force in this direction, plus Fr cos theta is equal to ma. That is equation number 2. If we multiply equation number 1 by sine theta and putting the value of n sine theta from number 2 equation, we will be getting this equation. Upon solving, we will be getting acceleration as this, and this will be your answer. So trust you have understood the concept of solving it. In case of any doubt, please do write in the comment box. I will clarify. Thank you.